Mr. Moore's math class!
Good afternoon, guys, and welcome to Mr. Moore's online flip classroom. And boy, am I excited to be teaching you today, because we're going to look at how to sketch the graphs of quartic functions. Now, as we go through this, some of you guys might even realize it's actually quite similar to sketching the graphs of cubic functions that have been given to us in this form. But all we've got to do is just follow an extra step or so. So without any further ado, let's go through and look at a little bit of an introduction on how to sketch these functions. Let's check it out.
Alright, so in today's lesson what we're going to do is look at how to sketch the graphs of quartic functions. Now, just like when sketching the graphs of cubic functions, there's 4 simple steps that we need to follow. Step 1 is to find the y-intercept. Step 2 is to find the x-intercept by making y equal to 0. And remember, if you've got one type of x, you need to use inverse operations in order to be able to solve. If you've got more than one type of x, what you need to do is factorize in order to be able to solve. Step 3 is to plot the points on the axis and identify the different types of intercepts that there are. And we'll come to that again in a second. And step 4 is to go through and sketch the graph showing all points of interest. Remember, you can use a CAS calculator to assist you with this if necessary, especially when finding out the turning points, etc. Now, coming over here and having a look at the different types of quartic graphs that you can get. This one here is a basic quartic graph, that is y equals x to the power of 4. Now, if you have a look here, it starts off very, very flat, because if you put a fraction to the power of 4, so for example 1/2 to the power of 4, you get something like 1 over 16. So therefore, anything below 1 is actually going to be really quite flat, but anything above 1, what happens is the graph gets steeper and steeper quite quickly, to the point where at 3 it becomes 81 along the y-axis. So as I said, it gets very steep very quickly after the x-coordinate of 1 or -1. Now for this graph here, you can see that it's actually got 4 intercepts, 1, 2, 3, 4, and because it's a quartic, that's what you can expect to have the most intercepts that it can have, that is 4, because x to the power of 4 intercepts. Now these intercepts are going to be at the coordinates a0, b0, c0, and d0, which you can get from this equation here. Now, because each one of these are linear factors, you are going to get linear intercepts, that is, just ones that go straight through the x-axis. Having a look over here at this graph here, what you can see is it's actually got a turning point that comes and occurs just at this point here, and that's actually at the coordinates a0. Now we know that that's the case because if you have a look here at this factor, you've got x minus a squared. So when you have a factor squared, you get a turning point on the x-axis, just like we discussed when sketching cubic functions. This coordinate here will be at b0, and this coordinate here will be at c0. So therefore, quadratic factors result in a turning point at the x-intercept. Now if we have a look over at this last graph over here, what we've got is this intercept here will be at a0, and this intercept here will be at b0. Now how we know this is because, as you can see, this here is just a linear intercept, that is, it just goes straight through, whereas this one over here, it comes up, becomes flat, and then goes back up again, and as we know, that is called a point of inflection. So in order to get a point of inflection, you need to have a cubic factor. So therefore, cubic factors result in a point of inflection at the x-intercept.
Sweet guys! So then I guess if the polynomial is made up of linear factors, it's going to go straight through the x-intercepts, such as what you can see here. And of course, if the polynomial has a quadratic factor, it's going to actually have a turning point at the corresponding x-intercept, such as what you can see here. And, of course, let's not actually forget about the cubic factor. If it's got a cubic factor in it, then it's going to have a point of inflection at the corresponding x-intercept, such as what you can see here. Alright, so now let's have a look at a couple of worked examples on how to actually sketch the graphs of these functions. Let's check it out.
Okay, so it's now time for a worked example, and as you can see, it says sketch the graph of y equals x multiplied by x minus 2 multiplied by x plus 3 squared, showing all points of interest. Alright, now the very first step, as you've seen before, is to go through and find the y-intercept. So to do that, we find the y-intercept, you make x equal to 0. So we go through and we write out the equation of the line, that is y is equal to x multiplied by x minus 2 multiplied by x plus 3 squared. Make x equal to 0, so we've got y is equal to 0 multiplied by 0 minus 2 multiplied by 0 plus 3 squared. Therefore you get y is equal to 0 multiplied by negative 2 multiplied by 3 squared. And 0 multiplied by anything, of course, will get us 0, so y is equal to 0. Therefore, the coordinates of this point are at 0, 0. And we'll just go through and highlight that because it's going to be important for us later. Now what we need to do is find our x-intercepts. So for our x-ints, we know that we need to make y equal to 0. So write out the equation line again. We get y is equal to x bracket x minus 2, x plus 3 squared. Go through and substitute in 0 for y now, so you get 0 is equal to x, x minus 2, x plus 3 squared. Alright, so what we need to do is solve each factor separately. So therefore we need to go x is equal to 0, x minus 2 is equal to 0, and x plus 3 is equal to 0. Therefore x is equal to 0, x is equal to 2, and x is equal to negative 3. And the coordinates of these points are 0, 0, 2, 0, and negative 3, 0. Go through and highlight these because they're important for when we need to go through and plot them. And as you can see, the next step is to plot these points and identify the types of intercepts. So let's go through and plot them. So the very first one, the y-intercept is at 0, 0, and we'll just write 0, 0 like so. The next one, well, the x-intercept also at 0, 0, so I've plotted that already. Great, we don't need to do it again. 2, 0, 2, 0, and negative 3, 0. Negative 3, 0. Alright, now we've got 3 dots, but that really doesn't mean too much to us because who knows what the shape of the graph is going to look like. Well, we can actually figure that out from the equation of the line. There's y equals x multiplied by x minus 2 multiplied by x plus 3 squared. Now we know that it's a positive because there's no negatives out the front of the x, so that means the graph must end up going up after the last x-intercept, so that means it must go up there. Alright, if we have a look now at all the different types of intercepts, now we know that at the x plus 3 it's going to be a turning point because it's a quadratic intercept, so therefore it's going to be a turning point at x plus 3. So it's going to look something like that. Now at the x and the x minus 2 factors, that means it's going to be linear, so therefore at 0, 0 it's going to be linear, and at 2, 0 it's going to be linear. So 2, 0 it's linear, and we know it's going up. 0, 0 means it must be going down, and we know that this is a turning point, so therefore we've actually got the right angle there, because it's going to come from up here, going down, and it's going to go back up, coming down like so, going through there, and continue on. But we need to know exactly where the turning points are going to be so that we can actually sketch this graph accurately. Now the only way that we can get the turning points at the moment is through using the calculator. So we're just going to go into that, and we're going to go into a graph page, and we're going to go through and type in the equation of the line. So that is x multiplied by x minus 2 multiplied by x plus 3 squared. Press enter. And as you can see, the graph doesn't actually fit nicely in the screen, so what we need to do is change the window settings to what you can see here on Asset of Access on the page that we've been writing on. So therefore you're going to go Menu, you're going to go down to Window Settings, going to go Window Settings here, and then we're going to go through and write in all of our values. So x minimum is -5, our x maximum is 5, we'll leave our x scale as auto, our y minimum, well that's -20 on our graph, our y maximum, well that's 50, and our y scale, well that's auto. Press OK, and now we can see that we've actually got the whole graph sketched in our CAS calculator. So now what we can go through and do is find the coordinates of the turning points. Now we know that the turning point is going to be here at -3, 0 because of the type of intercept that it is, but let's go through and find the local maximum turning point here and the local minimum turning point here. So in order to do that, we're going to go Menu, Analyze Graph, we're going to go Maximum, and we're going to go to the left of the local maximum, to the right of the local maximum, and then you can see here that it's at -1.22, 12.4. So let's go through and plot that on our graph. -1.22, so it's roughly here, and 12.4, so that's roughly there. And we'll write in -1.22, 12.4. Then what we're going to do is find out the local minimum. So we go Menu, Analyze Graph, Minimum, go lower bound, go upper bound, and as you can see it says minimum is going to be at 1.22, -16.9. So we go over to 1.22, -16.9. 1.22 is around about here, -16.9, that's 12, 14, 16.9, so it's around about here. And we're going to plot that point there, so it's 1.22, -16.9. Alright, now that we've got all of our points, what we can do is just join the dots. So we know that the graph's going to come down like so to this point here. It's then going to go up to its local maximum turning point here, come down through the x-axis at 0, 0 to its local minimum point here, and go straight up through like so. Now what we can do is draw arrows on the end of the graph to show that it continues on, and what we need to do is just write out the equation of the line. So that is y is equal to x multiplied by x minus 2 multiplied by x plus 3 squared. Alright, so it's now time to press pause and attempt the following question, that is, sketch the graph of y equals negative bracket x minus 3 multiplied by x plus 1 cubed, showing all points of interest. Remember when you're done to press play so you can check your answers out against mine. Alright, so welcome back. Now, first of all, I've gone through and I've found the y-intercept by making x equal to 0. So I've written out the equation of the line as you can see here. And then what I've done is I've made x equal to 0. So you get y is equal to negative bracket 0 minus 3 multiplied by 0 plus 1 cubed. Now 0 minus 3 is negative 3 and 0 plus 1 is 1. That gets us y is equal to negative multiplied by negative 3 multiplied by 1 cubed. Now 1 cubed is 1. Multiplied by negative 3 is negative 3, multiplied by the negative is positive 3. So therefore the coordinate of this point is 0, 3. Coming over to our x-intercepts now, I've written out the equation once again, and now I've written in 0 for y. Now what I need to do is go through and solve each factor separately. So I've got x minus 3 is equal to 0, and x plus 1 is equal to 0. Therefore x is equal to 3, and x is equal to negative 1, getting me the coordinates 3, 0, and negative 1, 0. Now what I need to do is go through and plot these points. So coming over here to 0, 3, it's going to be up here at 0, 3 like so, and 3, 0, so I go over to 3, 0, and negative 1, 0. Now I'll go through and write out the coordinates of these points. So therefore we've got 3, 0, 0, 3, and negative 1, 0. Now as you can see from the equation, it says y equals negative x minus 3 plus 1 cubed. So therefore the graph's going to end up going down. So if we go over to our last x-intercept, we know that it needs to go down at this point here like so. Now the next thing we need to consider is what type of intercepts are they. Now this one here at x minus 3, well, at the coordinates 3, 0, it's actually just going to be a linear intercept, so therefore it's going to go straight through like so. At the coordinate negative 1, what it's going to be is a point of inflection, as you can tell from this x plus 1 cubed factor there. So because it's going to be a point of inflection, what's going to happen is it's going to go up like this through this point like so, leaving with a point of inflection there like you can see. Now what we need to do is go to our CAS calculator in order to be able to find the coordinates of the turning point. So let's do that. Alright, so now that we're in our CAS calculator, we're going to go to the graphs page, and we're going to type in the equation of the line, that is negative bracket x minus 3, x plus 1 cubed. Press enter, and up comes the graph. Now of course, as you can see, this whole graph doesn't fit in the screen, so what we need to do is we need to change the window settings. So we'll go menu, window zoom, go window settings, and we want our window to basically represent what you can see in our graph here. So we know that our x min is going to be negative 5, our x max is going to be 5, we'll leave our x scale as auto, our y minimum, well you can see it's negative 20 there, our y max, well that's going to be 30, and we'll leave our y scale as auto. Press OK, and now you can see our graph actually fits within the screen. So now what we want to do is we want to find out our points of inflection and our turning points. Now we know already that our point of inflection is going to be over here at negative 1, 0 because of the factor being x plus 1 cubed. But what we don't know is whereabouts this turning point up here is going to be. So in order to do that, we're going to go menu, analyze graph, maximum, go to the left, so lower bound, go to the right, so upper bound, and that there, as you can see, is at 227. So what we're going to do is come over to point 227 and plot it. So 2, 22, 24, 26, 27, like so, and we write 227. And now what you can see is this graph is starting to take shape because we've got the point of inflection here. It's going to go up through the point 03 to a maximum point of 2 at 227 and then come down. And you can always use the picture on your CAS calculator as a point of reference. So let's go through and do that. We're going to go up through this point of inflection, so level out, come back up through here like this, maximum point at 227, comes down through 30, and we draw arrows on either end. Now remember, when you've done that, what you need to do is go through and write the equation of the line. That is, y is equal to negative x minus 3 x plus 1 cubed.
Alright guys, so thank you very much for tuning into today's lesson, which was all about how to sketch the graphs of quartic functions. Now of course, like always, make sure you stay tuned for the very next lesson, because we're actually going to look at how to work with domain and range and function notation. So, like always, make sure you say hi to your maths teacher for me. Pawsey out.